Young's double slit again with a super old thing. Okay, so we're looking at a super old FET virtual lab setup. And what we can do with it is we can have this speaker generate light for us, which I know that sounds weird to say, but remember, light's just a wave. And if we put a double slit here and we kind of move it around, one, we kind of mess things up, so let's let things kind of settle down a bit. But as we let things settle down here, do you kind of notice how we have some red here and then some red out at the edges? This is the double slit. This is the interference pattern causing darkness and causing bright spots. And if you look at the intensity graph, we see a peak here, we see darkness, and then we see it starting to peak up. And if we change the color of this, or the wavelength, let's go to like an interesting blue. If we change the wavelength of this, you'll notice that we have shifted in these fringes. We can start seeing that fringing pattern a little bit more there. So we actually do see these kind of interference patterns for something like this. Here, let's just bring these in a little bit more. Can we get even more fringes to show up there? And let's see. So with the blue light here, even shorter wavelength. Yeah, we get our peak. We get some stuff here. One of the interesting things about things like this is that the intensity is proportional to the slit width. So if I increase the slit width like this, the intensity is going to change on this end. We actually see something kind of weird occurring here because that's such a small slit in comparison to our wavelengths. So let's do that. Let's separate. Let's have a larger D here for our slit separation. And if we see this here, note we have seen now with a large slit separation, we actually see a lot of these little fringe patterns. If we, let's try to make this a little bit brighter here. We can see them like here, 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 here. Oh, look at that. See, look at all of these fringes here. So with a larger slit separation D, we'll actually see more of our nodes here. They're more tightly packed. And if we increase our slit width like this, what we're going to see here is that the peaks kind of stay in the same spot, but we actually see a slightly kind of different light pattern in terms of the brightness just because there's more throughput. But this is what's going on here. As you increase this slit separation, you increase the number of fringes that you're going to see here, simply because D is larger. Whenever you change your slit width, you're going to get more throughput on that light as well. And when you kind of slide your barrier into different spots, we'll slide ours very far away and see what's going to go on here. Note, we don't have as much interference here. So things that like quickly, like this light can't even get that interference, which is kind of annoying. But if we pull it way back here, we see some other like really weird effects as well because we're not actually getting that wave to be here to begin with. So this is just going to kind of flatten out. So you want this barrier to be in such so that if we look at this here, the light is striking it. We do hit, the light kind of comes out. We do see these interference patterns. So let's just move our barrier back a little bit and see if things change. And if we move it back a little bit, we give this some time to settle out here. We see that this looks like it kind of peeled out slightly. So as we brought the barrier closer, these kind of peeled slightly. See less fringes there. So that's what's kind of happening here when we just take a look at it this way. We're actually going to swing back and see what this looks like in real life now in the lab. So let's take a look in our lab real quick in the virtual 226. So here we're on Joey Cam. And when we're taking a look at this, let's take a look at a laser pointer that is being shown through a double slit, so to speak. And this is actually going to be something a little bit more than just a double slit. We're going to talk about it in a later video. It's called a diffraction grating, but it's just like a very, set up many times double slit. So if I grab it, here's my laser pointer. We've got just nice green light, which we can see kind of bouncing off the walls there. If we kind of, let's dim the lights and turn off the bat signal. And here, let's go back here and turn off some more lights so we can just get a nice view of the laser pointer. So there's our laser pointer on the wall. It's super bright and everything's blurry now, which isn't cool. But when we shine the laser pointer through the diffraction grating, or like a double slit, so to speak, notice how we see multiple points of light in existence now. And you'll actually see 3 of them. The one on the far left is actually the central node here. That is actually the central maximum. The one on the right is the first order fringe, and then the one on the wall, we actually see where it is right there, simply because the wall makes a 90-degree turn, but it would be the second order fringe. So we're actually seeing like this light splitting up because of these slits in the diffraction grating. And one of the really cool things about this is like a transmission grating, because we can go through it in order to see it. But you can actually have a reflection grating as well. This is an old Logger Pro 3 CD. It's just a CD. You can do this with Blu-ray as well. But if you shine the laser pointer off of the data on the disc, you can actually see the multiple points of light as well. It acts as a reflection grating. So you still see these kind of wave interference patterns due to this. It's just a matter of, what we're looking at, what we see, and how it kind of works itself out. So that's what we're looking at there. When we see these kind of interference patterns, it's kind of a neat thing. But it is just, in the end, light shining, on these 2 different paths. Since the paths have different lengths to them, the light is interfering, and that light is destructively interfering in such a way that we get these dark fringes everywhere. So kind of cool stuff. The one difference between the diffraction grating and the double slit, and we'll talk about this later, is on the double slit, we kind of see these like bleeding edges on the graph, as this kind of looks Gaussian in nature, but we kind of get these like wings. The double slit has this. The diffraction grating just has nice peaks everywhere. We'll talk about why that is in a future episode. But for right now, this is what we should be seeing in terms of the Young's double slit and why the d sine theta equals m lambda equation works so well.